So here we're dividing. Again, sometimes you'll see this like this. I think last year on the exam, they used that divide symbol. When was the last time you saw that divide symbol in math? How long has it been? Not too long. Oh, in synthetic division, some of them had those ones? Okay. But we don't use it very much anymore, right? It's all use fractions. Is it the exact same? No. Because that exam is already, because that exam is already online. And if they decided to give the exact same exam as last year, then it's online. The answer key is online. You should look at it. No, I don't see it till the morning that you guys see it. I do know that the cover will be purple. So I did make photocopies of more reviews for you guys, so you'll have 3 copies. You'll have all the Manitoba ones, and then you don't have to print those out. So if you do those 3, then you'll have a good chunk, and then once you get to your 4th one, then you're going to have to choose either Saskatchewan, Alberta one to find and print out. Okay. So we're dividing y values. With dividing, there's one additional thing we have to consider, is you're not allowed to divide by 0. So you have to find out which of your 2 graphs is the one that's on the bottom of the fraction. And we see g of x is on the bottom of the fraction. So wherever g of x is 0, here and here, well, one of 2 things is going to happen. For the most part, you're going to have asymptotes. But if you, by chance, originally had a graph that's an x squared, and you're dividing by a line, it's possible that you could get one of those graphs with a hole in it. So you'll be able to see, based on what happens, whether you're going to have an asymptote or a hole when you're just given the graphs. But for the most part, start off by drawing the asymptote. Because even if you draw an asymptote and later find out it's a hole, it won't be the end of the world. So there's going to be asymptotes at those 2 places. And once we're done this example, I'll show you what is a possibility of happening when you're going to get a hole, and you'll realize why that happens. Okay, so there I've got my 2 asymptotes. Some things for dividing. What are easy numbers to divide by? Dividing by 1 is easy, right? Because it's going to stay the same. So I'm going to look, is my blue graph, because that's what we're dividing by, do we ever have 1 on the bottom? Is my blue graph ever 1? My blue graph has a y value of 1 there and a y value of 1 there. So when I divide by that, that's going to stay the same. So that it's going to stay the same as that red one and that red one there. What also is easy for dividing? Dividing by 2 is not bad. So here our y value is 2. Then you would cut that in half. So it's going to be a little bit of work. Okay, dividing by 2 is not bad. It's going to be a little bit of work. How about dividing by itself? Like 8.5 divided by 8.5. That's going to be easy. Anytime the numbers are the same, dividing is going to be easy. Well, where are the red and the blue graphs the same? Well, that's going to be exactly where they cross. So can you see at this blue and red point here? I'll draw the blue points on there. But can you see that the blue and the red points are exactly the same at those points? So there, your green graph is going to be at 1. So here's 1 on my graph. Estimate the x value. Problem with these first 2 points that we did, we're estimating our x values. Sometimes it's nice if you can actually find y values that are whole numbers. So when I'm looking on this graph, here my blue value is 5. That's a whole number. And here my red value is 2. That's a whole number. And that's some mental math that's not too bad. What's 5 divided by 2? Oh no, it would be red. Let's put this is red divided by blue, right? So I have to be careful there. So the red is 2, the blue is 5. What's 2 divided by 5? Two divided by 5, fractions, decimals. 2 over 5, yes. Where would you plot 2 over 5? Under 1. 2/5 is the same as 0.4. So there I would graph 0.4. And since it's symmetrical, you would have the same thing on the other side. Look at this point. The red point is 0. That's a whole number. The blue point is 9. What's that going to be when you divide it? That's going to be 0. So do you see that we have a fair number of points here, and now we can connect them. Since there's an asymptote, it definitely looks like your graph is approaching that asymptote. We have finished that middle section.
Have you decided to have a hole on that side?
I'll just make up an example and show you a possibility for the hole right after this. Okay. So there we go, we've got this section, but when you're graphing something, you need to graph the entire thing, and since we have asymptotes, we've right now only graphed between -3 and 3. We still need to add some points outside of that. Okay? Now what's going to happen outside of this is, and this graph isn't the greatest because it does continue on and you can't see nice points. But again, we decided that wherever the blue graph was 1, it stays the same. What about where the blue graph is -1? So here, the blue graph is -1. Here, the blue graph is -1. What would happen at those points when you divide by -1? Right? If I have 5 and divide it by -1, well, it becomes -5. It basically flips over the x-axis and just becomes the same value but negative. And one of the things I want you to notice with this graph is if I did take this point, which is at about, here if I go up on the red graph is at about 3, it'll be down here at -3 and -3. And we've got some points there as well. I'm going to show you what this graph looks like at this point. The reason, and it actually has an asymptote here, and some of the ideas that we can see for this. Now, for the most part, what's going to happen on your exam is they're going to give you nicer values and not as random as this. But I hope that you can see that if I'm going to take the red anywhere when x is bigger than 3, so anywhere this way, when x is bigger than 3, can you see that the red graph is always positive? Yes? Can you see that the blue graph will always be negative? And if you have a positive number divided by a negative number, you will always get a negative number. So that's the first thing that I can tell for sure, that in both of these sections on the outside, that my graph is going to be below the x-axis. It won't always work that you'll have it approach an asymptote like this. The reason it does approach an asymptote in this case is I can see that the blue is getting steeper quicker than the red. Can you see that? Can you see that the blue is getting steeper than the red? And so you're going to be dividing by bigger blue numbers than you're going to have red numbers. And so as an idea, when you're dividing by a bigger number, it's going to be getting closer and closer to 0. So those are some of the concepts. Now, someone said, how would you know if there was a hole in the graph? We'll just add an example here. I will put in some values. And this will be more typical of the kind of graphs that you'll see. So we're going to do red graph here. I'll do some nice points on this graph. It's a parabola. That'll be our red graph. We'll call this one f of x. We are going to graph f of x over g of x. G of x looks like this. So first of all, when we look at this graph and we look at our blue graph and we know that we can't divide by 0, we would say right here at -2, and I'm going to just start with an asymptote because most of the time those non-permissible values will be asymptotes. We're going to see in this example that it turns out to be a hole. Okay? And the only way that you could see that it turns out to be a hole is if you have lots of points on here. So I'm going to start labeling some of the points that I put on here. We've got 0, -4 on the red. We've got 1, -3. We've got 2, 0. And we would have 3, 5. Actually, 3, 5 would be higher up. Right here, actually, I think. See? Yeah, 3, 5 is right on that line. And over here, we would have -3, 5. We have -2, 0, and -1, -3. Those are some points on our red graph. And on our blue graph, I also have -2, 0. I've got -1, 1. I've got 0, 2, 1, 3. 2, 4, and of course 3, 5 is the same. And going in this direction, you would have -3, -1. Now I chose ones that have nice points so that we can divide them easily, and we're going to find out why there's a hole when we divide it. And we're going to also use some of the things that we learned in Chapter 2 with our rational functions, because when you're dividing two functions, a lot of times this will look like a rational function, because my f of x graph is some sort of x squared graph, and my g of x graph looks like a line, so it's some sort of x graph. So we have to think back to Chapter 2, and what happened when we had x squared graphs over x graphs? Well, we factored them first, and sometimes if things canceled out, there was a hole. And if things didn't cancel out, there stayed asymptotes. Now I'm going to say in this graph that we've drawn, I made one so that there would be, when it was factored, something would cancel out and there would be a hole. And we're going to see what that looks like. So first of all, if we take the red graph and divide it by the blue graph, let's go through the points. At 3, 5, the y values are both at 5. So when I divide them both, I'm going to get 1. So at 3, which is right here, I'm going to get a point 3, 1. The next time we have nice points, well, here at 0, the y value is 0. On the blue graph, the y value is 4. 0 divided by 4 would be 0. My y value on the red graph is -3. At 1, -3. The y value in the blue graph is 3. -3 divided by 3 is -1. At 0, I've got -4 divided by 2, -2. And at -1, I would have -3 divided by -1, -3. And here I have an asymptote, so I'm going to leave that out. But when I go on the other side of the asymptote, I've got 5 divided by negative 5, which is there. Can you see that my dots are sort of lining up in a straight line? They don't have the same swooping nature that we had in the last one, which made us think it's swooping up towards the asymptote. They're in a straight line, and so when I go to connect them, and if you had gone one more point, you would have found that, which is telling us there's probably going to be a hole, and that hole's at negative 2, and according to the pattern we see, negative 2 comma 4. Negative 2 comma negative 4, thank you. So what did I do? What graph did I graph originally? Can you tell by looking at the graph? Think of transformations unit. What's the red graph? It's an x squared graph. But what kind of x squared graph is it? X squared minus 4. The green graph is a line. The blue graph is a line. Can you tell me the equation of that line? X plus 2. Can you see that when you factor the top, x minus 2, x plus 2, and having the bottom being x plus 2, those would cancel out, and that would give you a graph with a hole. Okay? One of the things you're going to use as a strategy in this unit when you're dividing graphs or multiplying graphs is thinking, what graph did I have to start with? Here I have the red graph is an x squared graph. The blue graph is an x graph. And what happens when I take an x squared and divide it by x? Most likely, I'll get a line. And what's going to happen in your two situations here, which we saw in Chapter 2, in Chapter 2 we saw two different types of things. One was the hole, which we have right here. And when there wasn't a hole, we had an oblique asymptote. And with the oblique asymptote graphs, say you had an oblique asymptote here and a non-permissible value there, what happened in the end is your graph looked like this. And the idea that we see is as it gets further and further away from 0, as it goes further this way and further this way, it gets more like the line that it's supposed to look like. And that's what's always going to happen when you do an x squared divided by an x. If you do an x cubed divided by an x, your graph will eventually start to look like a parabola. Okay, so that is the end of this, and now we can get into some actual questions.